Hello, I'm Rick Riss. I'm a senior consultant at ARC. Welcome, Graham.
Thanks, Rick.
So, Graham, Corys has been in business for quite some time. You make a range of simulators for different industries. Can you describe the different types of simulators you guys provide?
Absolutely. Yeah, we work across, as you said, work across a wide range of industries. In the process industries, we work in oil, gas, chemical, really any manufacturing process. And we produce high fidelity process simulators. We're the world's largest fully independent simulation company and are fully vendor agnostic. We also work in the transportation industry, especially in rail, and have a very large a very large market share of the global rail market for operator training simulators. And then, we as a company also started out making nuclear simulators in France and build a lot of different types of nuclear simulators for operator certification and training and site certification and training around the world.
So, presumably you make high fidelity simulators because you want to have an accurate representation of how these processes work so that operators can be trained on how the actual process will behave. Can you elaborate a little bit about what you mean by high fidelity in the chemical, oil and gas, and nuclear industry?
Yeah, absolutely. So, depending on the process parameter, we're talking about at maximum within 0.5% of tolerance of the actual heat and material balance and physics data for the facility. So we work really hard, and in many cases it comes down a lot less than that. We work really hard to make sure that our simulators are as accurate as possible because they're not only used for operator training, where that realism is extremely important for operator buy-in to their own training to make sure that they're looking at the right thing and seeing the right thing and that it matches the actual plant behavior, but then also as an engineering tool. So our simulators are used a lot in plant engineering and front-end engineering design programs and as part of greenfield projects where what we're doing is doing design for the facility, helping with equipment sizing, helping to validate what the design engineering group has done, and then really putting it all together dynamically and then attaching it to a control system. And we're rebuilding the controls within our own platform by emulating the control system early on to say what we think the best type of control should be based on the high fidelity process simulator. So that level of accuracy, both for engineering as well as for operator training, is extremely important in many cases.
So the owners of these facilities would like to verify that their operators are actually certified or trained or have reached a certain level of competency. How does that differ in the oil refining industry and the nuclear industry?
There are wide differences. So, it depends country to country, depending on the industry as well. So in the process industries in oil, gas, and chemicals, here in the United States and in the Americas in general, things are less regulated in terms of operator certification. It comes down in many cases to your operations excellence departments and what it is, how good you want your people to be, how well you want them to be able to respond to problems. And so then native to our platform, native to our simulation platform, we have a number of different training tools that are included in the Indus Plus product, which is our high fidelity simulation product. And that are both centered around performance monitoring, individual testing of different types of scenarios, be they practice scenarios for things that people are going to be doing, infrequent operations or abnormal or casualty operations. Those can all be pre-scripted and pre-built within the tool itself, and then trained to, and we can certify that somebody has achieved a very particular score within a very particular scenario, and then also with different variables added to it. So if we want those people to be able to show that they can handle those problems in different types of environments or with other anomalies going on, we can build all of that into the scenarios itself. It's a little bit different in the nuclear industry that we build simulators for, because everything, at least in the United States and in Europe in general, that's controlled by the regulatory agency. In the US here, the NRC. And the training program is specified, and then we build the simulator such that it can meet the exact training program to do what it needs to do to meet the intent of the NRC certification process. So on one hand, in process industries, you have organizations that are trying to be as good as they can, trying to train their people as well as they can, protect their assets, look after equipment and personnel safety. And then on the other end, you have government agencies that are dictating exactly what needs to be done for licensure of those people and those facilities. So it really varies. And then in the rail industry, you have different things going on, especially with positive train control, making sure that the train drivers are paying attention very specifically to all of the hazards, whether you're operating a tram, a subway station, or a subway, or I'm just going to pause. So whether you're operating a tram, a subway, a high-speed train somewhere in Europe, you need to be able to pay attention to different hazards such that the organization can certify their people to operate those trains safely.
So obviously these are high consequence processes that require competence on the part of those operators. You must have to then develop various types of scenarios. Obviously, I would assume startups and shutdowns, maybe it's a little different in trains, but startups and shutdowns are a key thing. But there's also the issue of training field operators, console operators. How does that change between, say, nuclear and oil and gas?
So again, it varies widely. So in the nuclear industry, you have an entire shift where you have a watch team that's trained to operate together as one. And everything having to do with the communication, the control, the coordination, the response to the scripted activity that's being done, that's all coordinated as part of a watch team activity, and everybody trains together no matter what. The other piece of that in the nuclear industry is that you're training on a physical simulator. So a simulator that's built to have the exact same look and feel of the actual control room itself. So the simulators there are an exact one-to-one, and you have the control room operators operating and training with the field operators in a number of different ways, but they learn to do it all together.
So that's basically a full scope simulator. I mean, it is, I think, a whole building.
It is
replicates the office. The dimensions of the buildings and the cabinetry is the same as the real control room.
Yep.
That's kind of expensive.
Exactly. It is. It is a full scope simulator, and those are large investments that are made, and again, that's for licensure of those particular facilities and of those operators, and it's dictated by, or it's mandated by the governments and the regulatory agencies within them. So then in the process industries, you have people doing things in different ways, and we have the latitude to do what makes sense for your organization within the process industries, and we have the software that can pull it off. That's the most important thing. So being able to include control room operator training with field operator training, whether you're utilizing our virtual reality product called VESA, or you are leveraging mixed reality or augmented reality, all of those things can be attached to a high fidelity process simulator if you already have one, or they can be built independent of that. So we can build virtual environments that are independent and not connected to dynamic process, high fidelity process simulators that are for any one of a number of different things. They can be for upfront facility familiarization, they can be to run through situational awareness scenarios, really a host of different things. And we work with organizations to work on a strategy for learning, operations, and certification that makes sense for their people and what it is they'd like to do.
Graham, thank you so much for your insights and observations today. Really appreciate you taking the time to visit us here at ARC.
Great. Thanks a lot, Rick. I appreciate being here.
We've been speaking with Graham Provost, Vice President for Strategy and Business Development at Corys. Thank you for watching.